Hello, my name is Ivana, and now let's move on to the abstract for this project. This study delves into a serene recreation area located 3 miles from the main water pipeline, featuring 30 hostel rooms up to 5 occupants and alluring pool for relaxation and enjoyment, emphasizing the crucial role of water in sustaining the environment and ensuring recreational functionality. The research highlights its significance for cleanliness, landscaping, facility requirements, water-based activities, and overall ambience. To meet growing demand and enhance accessibility, the report recommends a thorough examination and redesign of the water supply infrastructure. The proposed solution involves installing an efficient, customized water distribution system for the recreational area. Informed assumptions supported by calculation in mathematics and fluid mechanics guide the project to provide a comprehensive solution that addresses both present and future needs, ensuring the ongoing success and charm of the recreational area. Now let's move on to the introduction part for this project. For the introduction, it is situated in a quiet neighborhood, just 3 miles from the main water pipeline. This recreation area provides residents and guests with a peaceful haven. This beautiful location has a group of 30 hostel rooms that can hold 5 people each at a time, a large swimming pool that adorns the sceneries, and promise moments of relaxation and enjoyment add to the charm. Water's diverse role in maintaining many aspects of the environment makes it essential to recreational areas' functionality. It is essential for keeping swimming pools clean, supporting vegetation and landscaping, fulfilling the requirement of hostel facilities. Facilitating water-based activities and adding to the general ambience, water is essential, a necessary component for the successful operation and lieu of recreational areas, as it is served both functional and aesthetic purpose. To fulfill the increasing demands and provide easy access to this oasis, a comprehensive review of the current water supply system is necessary. It is suggested to create and put an effective water delivery system that is specifically suited to the need of the recreational area in order to meet their needs. Throughout the course of this project, reasonable assumption will be made by using calculation of the various parameters involving mathematics and fluid mechanics. These calculations are needed in order to develop a comprehensive solution that not only meets the needs of the present but also look ahead to the future requirement. One of the problem statements for this project is insufficient water supply for swimming pool, especially for swimming pool maintenance, as it can lead to risks to cleanliness and safety protocols of the pool, thus reducing the overall satisfaction of guests. Second is no reliable water supply in any of the 30 hostel units. Each of them are intended to accommodate 5 people. And then for the last problem is hazard to fire safety measures is also one of the constraints that might be faced in this project.
The objective of this project is to ensure a continuous and reliable supply of water to meet the demands of consumers and to prioritize customer satisfaction by delivering water services that meet their expectation, and then to implement and maintain the system in a cost-effective manner. While the scope of project is emphasizes evaluating and modernizing infrastructure, addressing vulnerabilities in pipelines and storage facilities for enhanced efficiency and future preparedness. A future-centric approach prioritizes satisfaction through clear communication and quick issue resolution. Additionally, a focus on cost-effective operation includes through cost analysis, optimizing resources utilization, and incorporating sustainable and affordable solution in system design and management.
This is the schematic design of this project. So as we know in the question that stated is the pipeline is 3 miles away from the main water sources. So in our project, we will conclude 2 centrifugal pump, 3 globe valve, and a water tank. Before we proceed to the calculation part, this is a few assumptions that we made in this project. First, the water demand of one person is 100 gallon per day, and times it with 5% in one hostel. So in 30 hostel, we have 15,000 gallon per day of water supply. And then, including the large swimming pool, which is 40 gallon size of swimming pool, the assumption that made is the water loss due to evaporation, splash out, backwashing, and topping up is 10 gallon per day. For the calculation involved, first from the total of flow rate that we could obtain from the assumption, we have to use a continuity equation Q equal to AB, and then after we obtain the V from the continuity equation, we proceed to calculating the Reynolds number and plotting the Moody chart, which is in this project. We obtain the flow is in turbulent flow. So according to the Moody's chart, we get F equals to 0.04. And then after we calculating the F, so we can calculate the coefficient loss of our total heat loss, which is major heat loss plus with minor heat loss, and then the loss is obtained is the total loss, which is 1.399 times 10 to the power of -3 meters. After we obtain the total heat loss, we can proceed to the Bernoulli equation, which is in this Bernoulli equation, we will cancel out the P1 and P2 because the pressure is equal to the atmospheric pressure, and our V1, which is our huge tank, and then the datum is Z1. So in this equation, we will obtain the HA, which is our head added in pump. After obtaining the HA, we will continue calculating our pump performance, which is PF equal to rho GQ times by HA. The result of the calculation, we will get our pump performance that will divide it by 776, which will lead to our horsepower. For the pre-selection part, the type of material has been selected in this project is cast iron pipe. Why? Because in durability, this cast iron is capable of withstanding heavy load and external pressure. For the fire resistant criteria, this cast iron usually are resistant to the fire, that has a very high melting point, that does not burn or contribute of the spread of the flame. For the lifespan, they are resistant to the physical wear and can make them a reliable choice for a long time water distribution system. And lastly, for the noise reduction, the cast iron will help in minimize the sound of flowing water and other noises associated with plumbing.
Now let's move on to the type of equipment. For the pumping system, the pump is a mechanical device used to transfer different fluids from one position to another. And best of the factors that should be considered before selecting a suitable pump for this project. The pump must have fluid properties like working fluid viscosity and vapor pressure of working fluid, specific gravity of working fluid, pump capacity, energy efficiency, environmental consideration, ease of use, and operating pressure. Based on the factors that have been stated, the pump that was used in this project is centrifugal pump. For the next type of equipment is globe valve. A globe valve is an industrial valve that is designed to stop, start, or regulate flow. It is linear motion valve where the internal discs can be adjusted to tinker with the flow of media. This assures the complete flow of obstruction of a particular medium. Unlike a few other industrial valves, globe valves are ideal throttling and controlling flow. Globe valves also can be used for the isolation of media. They are mainly employed in small piping systems to ensure complete control over the flow of medium. Now we move on to the next type of equipment, which is water storage tank. A water storage tank is a container that is meant to hold and keep water from different uses, making sure that there is a steady supply. These tanks are very important to community water system because they store water for high demands, emergencies, and normal use. A lot of time, communities choose water towers which are high tanks that can store water. These tanks are set up buildings or other structure to create gravitational pressure, which make it easier for the community to get water. The race design also helped with problem caused by geography and support the gravity-fed distribution system that is popular in city water network. This water storage tank can hold up to at least 500,000 gallons of water that are ideal for the recreational area.
So for the total cost is for this project is 1,150,000 ringgit. Why is it so expensive? This is because cast iron pipe itself is a very expensive. So in this project we use two different diameter of cast iron pipe, and as we know the question stated that it is 3 miles away from the main water sources, so that it will be concluded in this project. There's two different drop off in this project. One is with the diameter is 6 inches and another one is for the diameter 8 inches, a centrifugal pump and 20,000 gallon water tank. This is why this water tank is so big, because we need to have enough water supply in a day, as I mentioned in the assumption. So I think this 20,000 gallon water tank is suitable enough in this project.
Lastly, in the conclusion of this water distribution project ensures a reliable water supply for our recreational area through an integrated approach encompassing infrastructure improvement, customer-centric practices, and cost-effective strategies. Upgrading pipelines, pumps, and storage facilities, it reflects the project's commitment to resilience and preparedness for the future demands. Emphasizing effective communication and operational transparency fosters a positive relationship with the community. With careful material and equipment selection, along with a focus on cost-effective operations, the project serves as a blueprint for enhanced and resilient water delivery system, addressing both immediate and future demands while exemplifying effective planning and sustainability.